Sorry for the delay in recording this. It's been a challenge to try to get things done and find a quiet time to do some recording. So here I am at long last, and I apologize for the delay. So this should wrap up the rest of your packet. And for the chapter 2 alternate assignment, and you can go ahead and just scan it in and email it to me when you're done, and then I will change your grade. So hopefully that should it's got so many test grades in it, it should bring your grade for the quarter up to an A or B. So just make sure you get it done and turn it in as soon as possible, sooner rather than later, guys, if you can. Okay, I know you have until the end of next week, but if I get everything at the end of next week, it's not good because it takes way too long for me to get everything done. So I wanted to talk to you a little bit about the repetitive nearest neighbor algorithm. Even though that's not something that we covered, it's a little bit of an enrichment. It's the same process, and then I wanted to go through it, and then I'll do a little bit on the cheapest link algorithm. I'm going to skip some of the last page, okay? So, so far we've learned about the brute force algorithm, which always gives an optimal solution, but it's not always efficient. So we've noticed that, when you only have like four vertices, it's not so bad, but when you have 5 or 6, you end up having to do like 24 different outcomes. So it's really time consuming. And then we have the nearest neighbor algorithm, which is also approximate, but it's very efficient. So sometimes we'll use that. These days when we have computers and stuff, they'll do the brute force algorithm for us. But the nearest neighbor is a way to figure this stuff out without the use of a computer, which I think is nice. And then we have the repetitive nearest neighbor algorithm. So like the nearest neighbor algorithm, it's approximate and efficient. So what you're going to do is start at any vertex. Okay? And then from that vertex, you're going to apply the nearest neighbor technique. And then you redo that for every vertex on the graph. Okay? So of all the nearest neighbor circuits found, you're going to select the best circuit with the lowest weight. If the starting vertex of the best circuit is not designated as starting vertex, you can rewrite the circuit. And this is why we do this. Let me show you. So if I want to rewrite circuit A, B, C, D, A as it starts in vertex C, I'm going to write that as C, D, A, B, C, right? And then rewriting B, C, A, D, B as it starts in vertex D, I rewrite that as D, B, C, A, D. So do you notice I don't repeat the one that's in the beginning and the end? I repeat the new beginning. And then starting at E, we're going to do E, A, B, D, C, F, E. And then this one, we're going to start at vertex S, S, P, O, R, T, N, S. Okay, so the traveling salesman lives in town A and must visit clients in hometown and repeat the distance are given in miles. Use the repetitive nearest neighbor algorithm to come up for them. So what I want you to do is, if you have a minute, just go ahead and pause the video and try to do letters A through E, or A through D. If not, just follow along. So to do this one, I would go from A to B to D to C to A. Okay? And that is, I believe we got that as 150. I think so. Oops. did the wrong one. Okay, just check my work on that. I just did that very quickly. So, and then we're going to do B, starting from vertex B, we're going to go to B, D, A, C, B. All right. Because remember, the nearest neighbor always depends on the vertex you're starting with. It's not always the same. And then this one is CBD, AC, and that one is also 125. And then DB, CAD, and that's also 125. So which route would work? Any of these ones that are 125, sorry, that would be B, D, A, C, B, and then you could rewrite them accordingly. Okay, so not too bad. So let's go ahead and take that a step further. And we're going to start, for this one, we're going to use point A. So we're going to start from A, B, C, and D. So we're going to go ahead and do the nearest neighbor for all those. Pause the video would be really nice. It only takes a minute. Just go ahead and try to do these and then check your work. So this one is A, D, C, B, A, B, D, C, A, B, and C, D, B, A, C, and D, C, A, B, D. All right. This has a length of 80. This one has 74, 74, and this one as well. So all the ones that are 74 are what we're going to go for. All right, and we can rewrite any one of these starting at vertex A. So this one would be A, B, D, C, A, right? That is your new one written from vertex A, because we are concerned with, we want to do vertex A. So basically we're doing the nearest neighbor algorithm from each vertex and then choosing the one that works and then rewriting it starting at the vertex that we want to. So like here, we want to start from point E, but we're going to evaluate the nearest neighbor algorithm from every vertex and see what we get. So again, go ahead and give that one a shot. Okay, so this one I got ADBECA, and that was 89. And BDACEB, and this is CDBEAC. Since I spent some time going through the nearest neighbor, I'm not spending a ton of time going through how you would go about doing this. So, and then vertex D would be DBECAD, and this one would be EBDACE. So although this is requiring us to take some time to do these, it's not near as exhaustive or as labor intensive as doing the brute force algorithm. So any of these that have a length of 89 will work. So we're starting at vertex E, so I'm just going to go ahead and write the one that starts at vertex E, which is EBDACE, and that has a distance of 89, and that's our optimal solution. Okay, so let's go to the really hard one, which is the cheapest link algorithm. That's the one that always throws us. It throws me too, so I'm going to be honest. It's a pain in the tuchus, so just, kind of bear with me. I'm going to do the first three on this page. And then I'm going to skip the last page. So if you don't get the last page done, I'm totally okay with that. It starts getting really tedious and ridiculous on the other ones. So, and what I want you to do is try these and don't beat yourself up if you don't get them right, because a lot of times I have to do these several different times. So what you're going to do is first select the edge with the lowest weight, and then you're going to choose the next one and then the next one. But remember, you can't have a vertex with more than two paths coming out of it. And you cannot create three edges, and you cannot close the circuit. So you're going to have to keep doing that. There's going to be a total of, if there's, let's see, we have five paths, there's going to be 5 vertices. We're going to have 4 steps in this problem. It's always the number of steps, number of vertices minus 1. So for this one, I chose the smallest one, which is 1.2. So I chose 1.2, and then next there I had 1.4. So far, so good. All right. Then my next one, I have 2.1, but I cannot use that because that one's going to give this guy 3 edges coming out. All right, so I can't do 2.1, but I can do 2.2 because it's all by its lonesome all out here. And I can do 2.3. That gives both this and this 2 edges. So my last thing is I have to close the circuit, so I go right here. All right, so that one's not too bad. If I start at E, it goes from E, B, A, C, D, E, and I believe it has a distance of 9.9. All right, so I'm going to take you through the next 2, and I'm not going to add them up. I'm going to have you guys finish those up for me, because I just don't want to take too much of your time. I want this to be rather quick. But so there's 6 vertices, so there's going to be 5 steps. All right, so the first one I'm going to choose is the lowest one, which is, let's see, I've got a 40, a 60. So my 40 is going to be the first one I choose. And then I can choose 50. Yeah, I think I did this wrong last time. So let's try it. Let's keep doing this one. 50 and 50. All right. Now I can't connect this because that's going to give me 3. So my next thing would have to be 60. I can't do that one, but I can't do this one either because it closes this circuit. So I ended up doing this, and then this, and then this. And I don't think no, that's not what I wanted to do. So what I ended up doing for this one, let's go ahead and try a different method. This one you have to work on a few times, which is another reason why I just said don't do too many of them. I'm just going to do this one and we can stop there. So this one I did these 50 and 60, but I didn't do this 50. Okay. And then I did this and connected that, and then connected that. That one's definitely tedious. All right, so just do the best you can. I'm going to give you the path on the next one too that I did. Oops. This one, I did a little, it looks like a little fish. So I did these. and these, and let me know how you guys do. The cheapest link algorithm is the hardest one to do. It's not so bad when there's not so many paths, but it is a pain when there are a lot of paths. So just do the best you can on that. So just skip your last page. So just feel free. You'll have 7 pages to send me. And make sure you email me. And here is my email. You can actually scan it on, and there's a phone app that's free to scan in documents. So you can do that, or if you have a printer that does scanning, almost every printer does now these days, but there is a phone app that does scanning. For those of you that are going into college, it's a great tool. Um, for someone who took like myself, who took my entire second master's degree completely online, you have to kind of like, this is, frankly, this COVID thing is really good training for any of you guys who want to do master's programs, like after, if you go to undergrad and then want to do a master's program, because if you're working, which you most likely will be, master's programs, there's a lot of master's programs that are online. So um, and being able to do this stuff virtually is just a huge training for you. So let's just, you know, look at the glass half full. I am going to continue to post stuff mainly to get you ready for pre-calc and calc. Some videos and some little quizzes and stuff, but you obviously nothing's graded and stuff, but it's just enrichment to ensure that you guys are getting as much out of this time as possible. So those of you that are going into college and might have to take a placement test for math, um, I would strongly urge you to participate in this. Those of you who are going on and taking math next year, strongly urge you to participate in this as well. And I will have office hours up every day. So even if you aren't doing anything but would like to come and say hello, I would really, really love to see you guys. I miss you desperately. It was really hard not being able to say goodbye. So just please know that I care about you, and please stay in contact with me. All right. You guys have a wonderful day. And thanks again for doing this alternate assignment. I'm really proud of you guys.